This is the story of Earth. It is said the Earth was made 4.5 billion years ago, and 250 million years ago the supercontinent Pangea split into Gondwana and Laurasia. If this is how you believe the Earth was formed, then you've been living in a programmed matrix. Let me deprogram you with some scientific truth and logic that you probably have never come across. The evidence for my interpretation is all around you and can be easily seen and understood. Yes, it was likely that in the beginning there was one landmass, but it was probably larger than commonly thought. The ocean was smaller, shallower and warmer, allowing for the growth of large forests and vegetation mats. These vegetation mats were characterised by lycopod trees that grew up to 45 metres in height. Their trunks and roots were full of open spaces, presumably containing air. The roots are often preserved in a lamp brush pattern, which is characteristic of plants submerged in water. While it was also a long time ago when this supercontinent broke up, it wasn't millions of years. It was approximately 4,500 years ago. The land at that time was covered by lush rainforests and other biomes full of wondrous amounts of plant species, many of which are now extinct. Not only was flora bountiful, but the fauna was ever present, covering this great land, and it was ubiquitous within the temperate ocean, which was more like a large lake when compared to the oceans of today. However, beneath this land of beauty came the murmurings of a change so large that it would completely devastate the things that once were, and then change the earth forever. While there may be disagreements about the exact mechanisms of this occurrence, the catastrophic nature secondary to an immense amount of water is unmistakable within the geological record. One of the landmarks of this event is the Great Mid-Atlantic Ridge, which runs through Iceland and almost to the Antarctic. The large singular supercontinent rifted along this line as a huge magma change rose towards the continental crust. This one-off occurrence was of an order of magnitude not seen or experienced today. However, the scar has permanently affected the geological record along the Mid-Atlantic Ridge and elsewhere. Between the continental crust and the rising magma chamber was a large amount of subterranean water. This large reservoir of water was likely present within much of the Earth's crust under both continent and ocean. As it was compressed by the molten magma, its pressure and temperature increased exponentially. Over a short period of time, the subterranean water was pushed through the continental crust until it finally broke through, producing a huge fountain. The water blasted out of this crack in the Earth's crust and underneath the ocean as superheated steam. This crack likely encircled the globe along what was to become diverging tectonic plates. The immense amount of released water rapidly covered the globe, condensing into clouds, and fell as a large amount of rain upon the earth below. While it rained for 40 days, the fountains of the Great Deep likely kept expelling water for up to 150 days. It was not long until the whole Earth was covered by water. Noteworthy is the fact that if current-day ocean depths were raised and the large mountain ranges lowered, the Earth would be covered by 3,000 metres of water. As the falling rain, tectonic shifting, tidal waves and sheet erosion ravaged the land underneath, a large amount of geological change dramatically altered the underlying continents. Continental-sized sheet erosion is the possible cause for the great unconformity seen in the geological record. This represents an almost worldwide erosional event that divides rocks with familiar fossils from rocks with no fossils or only fossil bacteria. A great example of this is at the Grand Canyon, where the division is between the Tapiat sandstone and the early basement metamorphic rocks made up mainly of schist. The pre-flood continent had no such division, and the crust was covered with tremendous biodiversity. As the watery destruction ravaged the underlying continent with tsunamis and large tidal waves which could be pulled by the moon, the underlying erosion left behind a conformity towards the base of the geological column. It should be said at this stage that the full geological column is not seen anywhere on Earth today, and is only presumed to exist. What is actually seen is the evidence of brief, rapid and massive, in area and volume, sedimentation events which have led to a sedimentation column of between 1,500 to 10,000 metres thick. These layers have abundant evidence of being rapidly deposited underwater. Turbidity currents which are now well documented are sediment-laden moving water which in today's world are seen following underwater earthquakes or with submarine landslides such as seen off the coast of Hawaii. They rapidly deposit a large amount of layered sediment. For example, the floor of the western Mediterranean Sea has revealed a turbidite unit which is 8 to 10 metres thick and covers 60,000 square kilometres. A well-known submarine landslide is called the Storegga, which runs along the end of the continental shelf of Norway. Debris up to 450 metres thick is spread over a distance of 800 kilometres. Why are there virtually no such examples seen of this within the geological column in the continental crust? The reason, of course, is obvious. The evidence has been misinterpreted. For example, let us analyse the coconino sandstone at the Great Canyon. On the face of it, this layer would have to be one of the most difficult to explain as due to being deposited in water. It is the white coloured strip in the upper part of the Grand Canyon, 52,000 square kilometres in area and 96 metres in height. The traditional understanding within the geological community is that this sandstone was formed as wind-blown desert sediments. The evidence for this sandstone layer being laid down in a windy desert lies in its cross-bedding nature, the nature of the sand grades themselves, and trackways or fossilised footprints within the stone. Cross-bedding is a description of the layering of the beds on an angle, as seen in this photo, as seen in inclined beds within the desert secondary to wind-blown sand dunes. However, the trackways themselves are strong evidence of being deposited underwater. Dr. Leonard Brand of Loma Linda University of California documented 82 of the trackways from the coconino sandstone and compared them against 236 experimental trackways formed by amphibians underwater, on wet sand, and reptiles on dry sand. The trackways made experimentally underwater by amphibians most closely correlated with that seen in the coconino sandstone. Indeed, the trackways suggest that virtually all trackways were against the current and therefore going upslope in an attempt to get out of the water. Dry sand footprints were usually impressions without detail and therefore not at all similar to the detailed trackways of the coconino sandstone. The crossbeds themselves are also indicative of formation from underwater sand waves rather than desert sand waves. Most desert sand waves have an angle of 30 to 34 degrees, while the coconino angled crossbeds of 25 degrees are more indicative of underwater sand waves. These sand waves have been observed and also have been repeated in the laboratory. The size of the crossbed height is proportional to the sand wave depth and the depth underwater. The thickest crossbeds in the coconino sandstone are 9 metres, corresponding to an underwater sand wave of about 18 metres and an ocean depth of 90 to 95 metres. There is nothing in today's environment that can compare or reproduce with this kind of sand wave over such an area. It is only by the massive tectonic shifts associated with global flood that one could have created such an underwater sand wave. Another layer found within the Grand Canyon is the Bright Angel Shale Formation. This is a type of sedimentary rock called shale, which is thought to be derived from clay-rich muds. The three main evidences for slow deposition as per traditional geology are multiple thin lamina, burrowing organisms and shrinking cracks. We will deal with each separately. Each lamina, or visual bilayer, is thought to represent a seasonal alternation, which in turn represents a summer and winter deposition over a 1 year period. However, rapid deposition of lamina has been observed and repeated experimentally within the laboratory. In 1960, Hurricane Donna deposited 15 centimetres of thick mud with numerous thin lamina. In 1980, the eruption of Mount St. Helens produced a 7.6 metre thick layer of laminated volcanic ash. In the laboratory setting, it is seen that high-velocity currents sort and deposit sediment grains by weight, density and shape. Deposition of multiple thin lamina occur as a turbidity current loses velocity. Furthermore, it has also been shown experimentally that a current is not even needed to form a lamina. When a large amount of clay and silt is deposited en masse in water, lamina form rapidly from a grain penetration process. The coarse silt particles penetrate a certain distance through clay particles before they meet the resistance of the more compact clay, forming thin lamina. As more evidence accumulates that shales, i.e. mudstones, have indeed formed rapidly, and given that these mudstones occupy up to 2/3 of the sedimentary strata, a large reappraisal of the rate at which sedimentary rock is required. The other evidence for supposed long ages for deposition of shale is the presence of burrowing organisms. It is said that trackways of organisms represent cessation of sedimentation. However, this argument is almost nonsensical. Many terrestrial and marine organisms burrow within sediment and leave obvious evidence of their activity by completely disrupting and reworking laminas in clay-rich mud. Therefore, the very presence of lamina represent rapid deposition and formation into stone. Shrinking cracks are found in the Hermit Formation of the Grand Canyon. It is believed through long ages of drying and wetting, the clay-rich shale are desiccated and the sandy material from the overlying coconino sandstone infills from above. However, the Hermit Formation demonstrates filling from above and below, i.e. there must have been upfilling from a sandy layer below the clay-rich shale which had not been formed into stone as yet. Numerous examples of cracks being filled both from below and above discount the long ages assumption but are perfectly consistent with rapid deposition underwater. This is amplified by the fact that the traditional geological community believe the Hermit Formation is separated in time from the coconino sandstone by 10 million years. Are we to believe that the shrinkage crack stayed open for 10 million years until the sandstone was ready to be laid? This is of course nonsensical. Such cracks would be filled secondary to erosion of the underlying surface within that amount of time. Other than sandstone and shale, there is one other principal sedimentary rock, that is limestone, derived from the breakdown of carbonate-containing sea creatures. It is said that the ancient limestones are formed in the same way that today's shallow water lime muds do, that is, very slowly. However, the very nature of these old limestones are quite different. They are 4 micron-sized crystals of 99% calcite, whereas today's so-called precursor is dominated by 20 micron-sized crystals of mostly aragonite. Not only that, today's limestones have been seen to rapidly deposit by joining together in pelletoids, allowing particles to settle quickly. In regard to the red wall limestone at the Grand Canyon, it has also been argued that this was part of an ancient reef and therefore only built up slowly. However, there is virtually no evidence of coral or sponge reef structures within the red wall limestone. This is almost definitive evidence that it does not represent an ancient reef. However, there is a fossil called a nautiloid, which gives us ample evidence as to the mode of deposition of the red wall. A nautiloid is a marine organism which can grow up to 60 centimetres and lives in a shell. More than 1 billion are found fossilised within a specific layer of the red wall limestone over an area of 220 kilometres. The vast majority of these nautiloids are aligned in a northwest-southeast direction. This of course does not indicate random death of mature age nautiloids onto a motionless ocean floor, but instead indicates that the shells are aligned with the prevailing current. Any current able to induce such orientation would also be able to move and deposit lime mud. The sizes of the nautiloids indicate death of all sizes of nautiloids in keeping with a specific time within this population. This therefore represents a mass kill event by some watery catastrophe. To add more evidence to this supposition, the chert overlying this bed is chemically distinctive, possibly indicating toxic marine conditions. The limestone also has areas of cross-bedding up to 10 metres high, indicating underwater waves of up to 20 metres high. Extraordinary fossil preservation within limestones worldwide also suggest rapid burial and lithification, i.e. stone formation. Most of today's organisms do not lithify, i.e. form fossils, as they are rapidly degraded by scavengers and bacteria before burial or within shallow graves. Perfect fossils therefore require rapid lithification, and therefore as limestones go, rapid burial in water. The Santana Formation in northeast Brazil, where the fossil fish are described as the world's most perfect fossils, are found within limestone. As our discussion on sandstone, shale and limestone has shown, there is a significant amount of evidence for rapid deposition. This is just the beginning. Let us look at the amazing layering seen in the geological column. The joining formations of almost perfectly flat bedding planes and extend over tens of thousands of kilometres. This is exactly the opposite of what you would expect over millions of years of deposition and erosion. They instead should demonstrate irregular topography, as we've seen in today's eroded landscape. For example, the red wall limestone lies on the Cambrian mauve limestone with virtually no trace of erosion, but apparently represents 140 million years. Also, the coconino sandstone / hermit formation boundary has no evidence of erosion, but is supposedly separated by 20 million years. While it is claimed that flat erosion can occur, there is no current day equivalent that can be pointed at that even slightly resembles the large areas seen in the geological column. As a caveat, there are some layers that have channels eroded. However, these are insignificant compared to today's erosion and could well be explained by catastrophic erosion. However, such knife-edge precision is exactly what one would expect via flat sheet erosion from a tremendous amount of watery destruction and rapid deposition via turbidity currents. While it is true that ocean beds may not erode as much as continental sediment, many of these layers are thought to have been deposited above water, and therefore one would reasonably expect erosion interrupting the flat bedding planes evident within the geological column. Also, there is very little evidence of soil formation or burrowing organisms between these layers, which one would expect over millions of years. Instead, there is evidence of massive underwater erosion. For example, at the Great Unconformity in the Grand Canyon, large boulders of Shinamo quartzite and sandfield channels indicate erosion and catastrophic underwater debris flows, which were able to move up to 20-metre boulders for more than half a kilometre. Further evidence of rapid deposition is provided by sediment warping without significant cracking. Adjacent rock formations, supposedly tens of millions of years apart, seem to bend together without cracking the underlying rock. Surely after tens of millions of years the sediment would have lithified by compaction, and surely the rock formations would have had to fracture when folded rather than just bending together. Of course, this is not a problem if one assumes that the sediments were rapidly deposited on top of each other and then subject to tectonic forces prior to any stone formation or lithification. Clastic dikes are also evidence of rapid deposition. These are formed when liquefied sediment squirts up into the overlying layer or even layers of sediment. The extreme pressure of the overlying sediment causes the soft layer underneath to squirt up through cracks. Given that the underlying sediment would have had to have been millions of years older, one would have expected it to form into a stone, and therefore be unable to squirt up into the underlying sediment. Traditional geology therefore have to make the remarkable claim that the underlying sediment must not have turned into stone within that time. The only evidence of these supposed millions of years lies in the different fossils in the separated formations, and therefore significant presuppositions, and not on the nature of the stones themselves. Fossil-rich graveyards represent formations of densely populated, well-preserved fossils. There are multiple examples of these all over the world, from the Dinosaur National Monument in Utah, the Cambrian Burgess Shale in Canada, the Triassic Mont San Giorgio Basin in Italy, Switzerland, and the Cretaceous Chagota Formation in Mongolia. The evidence at all these sites scream rapid deposition from a watery catastrophe. Many of the organisms demonstrate burial while still alive. For example, clam fossils are found closed, organisms fossilised in the process of eating other fish, and organisms fossilised in the process of defecation. As mentioned previously, fossilisation of living organisms is a rare event, as they have to be rapidly buried in an anoxic, i.e. no oxygen, environment to avoid decomposition. However, these fossil graveyards are remarkable in not only the sheer number of fossils within a small volume of sediment, but also their well-preserved nature. The only reasonable explanation is rapid burial via sediment, either from a tectonic, watery, or volcanic mechanism, all of which were present during the global flood 4,500 years ago. We have discussed the overwhelming evidence of rapid deposition of sediment and rapid deposition of animals. There was also rapid deposition en masse of vegetation. a large portion of which form the rich reserves of coal all around the world. It has been demonstrated repeatedly by experimentation that vegetation can rapidly become coal at the right temperature, that is very high. While coal from the southern hemisphere is made distinctive by the leaves deposited, lycopod trees are seen in the coal reserves of the northern hemisphere. These trees have compelling evidence of being part of large forests that grew on water. They are supported by a floating peat layer of rotting vegetable debris. The tremendous amount of vegetation present on the fertile pre-flood Earth was rapidly ripped from both the large supercontinent and the water-based forests by a catastrophic movement of water. They were then deposited en masse and rapidly covered by hot sediment. Traditional geology claimed that peat swamps were the progenitors of the coal reserves and thus hold that the vegetation grew in the place in which they became coal. However, peat swamps are wholly unable to explain the evidence for rapid deposition seen in coal. For example, the lycopod tree trunks are nearly always separated from their roots and branches, demonstrating catastrophic conditions to tear away the trunks from their roots. They are found in all directions of repose, sideways, upside down and right side up. The roots themselves, called stigmaria, are often fragmented with their long axis aligned, i.e. in the direction of a water current, and are filled with sediment which is often different to the type of sediment that it is buried in. These detached roots are also found in multiple different beds, which can be completely penetrated by the tree trunks. They therefore bear little resemblance to roots that have grown in situ, such as today's peat swamps, and instead scream out deposition within flood conditions. Other features found in coal beds that demonstrate sorting by floodwaters include microlamination and salted granular texture. Flood conditions also explain fossilised marine organisms both within the coal and in the sedimentary layers found between coal seams. Of note, the conifer and fern trees found in coal prefer tropical soils and would not live in the colder areas of the earth which are known for peat production. Evaporation forces in tropical areas dry out peat swamps. In fact, virtually all plants seen in coal are not found in today's peat swamps. Today's coal seams can form single vast seams spanning over 160,000 square kilometres. No peat swamp can replicate this. The lycopod trees which are associated with coal seams are often found going through multiple strata which, according to traditional geology, traverse millions of years. How can a tree trunk remain in situ without degradation while millions of years of sediment form around it? Cannot happen. One of the counter-arguments is that there was not enough vegetation on the Earth to produce today's coal reserves. However, this depends on two faulty assumptions. One is that the compaction ratio of vegetation to coal is 12:1, while recent research suggests it was more likely to be 2:1. And it also fails to consider that today's desert and ice landscapes were probably full of vegetation at that time. Also, a large amount of the northern hemisphere's coal reserves seems to have come from floating forests. The first two stages of the flood have been described: initial devastation and massive erosion followed by rapid deposition. That concludes part 1 of the story of Earth. Part 2 will describe the third stage, which involves formation of virtually all our modern landscapes. As the water began to flow off the continents, both sheet and then channel erosion carved out the magnificent landscapes that are seen around the world. Catastrophic tectonic and volcanic forces built the large mountain ranges around the world. These are not able to be formed under today's conditions, as erosion outstrips the forces that create elevation quite significantly. Stay tuned for part 2 of the story of Earth. Hopefully we can get part 2 out before the middle of 2014.